Sir,
Can you tell me what are conductors?
sir,
It's okay. Take your time and tell me anything you know. Anything you know. No need to explain whole. You can give me a small point also that this is the function of conductor or insulator or anything. Don't worry.
sir, the substances which allow electricity to pass through them.
Okay, good. And insulators?
Which do not allow.
Okay, very well. So conductors are those materials which allow electric current to pass through it. Okay.
Hello.
Conduct. Yes, Rohit.
Sir, I joined late because I was studying for my computer's exam. Sorry, sir.
It's okay. We started discussing about conductors and insulators, so
Sir,
you
this
haven't
chapter
missed
is
anything.
done, so I'll just listen now, sir.
Okay, I have started now only. So
Okay.
I'm telling about conductors. Conductors are those materials which allow electric current to pass through it. Okay, so whenever we supply electric current through a conductor, it will allow for electric current to pass through it. Can you tell me? Okay, let me tell about insulator also. Insulators are those materials which does not allow electric current to pass through it. Okay, so conductors are those materials which allow electric current to pass through it, whereas insulators are those materials which do not allow electric current to pass through it. Can you tell me some example of conductor and some example of insulators?
Sir, conductors are metals,
Okay,
metals and graphite.
So insulators are like wood, plastic.
okay, good. Wood,
Sir,
Wood,
plastic.
plastic.
Fine. And give me particular
Sir,
example of
is
metal.
rubber an example of insulator?
Yes, rubber is an example of insulator. Good. Tell me particular example of conductor in metals
Metals,
also.
iron, metals.
Sir, water.
salt water.
Correct. Salt water, you can say.
So metal.
Iron.
Okay. In I will tell you about water also. What you said? Iron?
Acid.
Yes, sir. So all
Yes,
metals.
Sir,
not all metals.
acids.
What?
Acids.
Yes, acids also allow.
Sir, brass.
Bases.
Brass. Okay. Brass is a metal or non-metal? First tell me one thing. Is brass metal or non-metal?
Metal.
Non-metal.
Metal.
So, we have to see if brass allows current or not. Okay, brass conducts electricity. Fine, we can say brass also. we can say copper also, and we can say aluminum also.
Sir, gold.
Sir, bases.
Yes, gold also conduct.
Acids and
Fine.
bases.
Sir, cyanide.
Cyanide is a type of solution, right?
Yes, sir.
Sir, steel also contains.
Cyanide. Steel also contain. Yes, steel is a like alloy. It is the mixture of these copper and nickel. Okay, fine. And so these are some important example of the material which conduct electricity. Okay, in which the copper and aluminum are the good conductors. Okay.
Sir, even strong acids and strong
Fine.
bases are good conductors.
Yes, there are many examples of good conductors and bad conductors. So some of these are this. So can you tell me why conductors allow electric current to pass through it?
Sir, they have free electrons. In them, sir.
Okay. Conductors have free electrons. Okay. Do everyone agree with this statement?
Free electrons, sir.
Yes. Do everyone agree with this statement?
Yes, sir.
Yes, sir.
So if I am saying conductors have free electrons, so with respect to metal and non-metal, can you tell me which has free electrons? Metal or non-metal?
Metal.
Okay. So metals. Can you so that means non-metal should not conduct, right?
Sir, but graphite can conduct.
I'm not talking about exception. I am talking about non-metal in general. Apart from graphite, there are many non-metals. So tell me, can non-metal conduct an electric current?
No, sure.
Sir,
Only
on some conditions they can, sir.
So non-metals. So first thing is that every material conduct, but it depends how much it conduct. So metals are good conductors of electricity.
And non-metals are poor conductors.
Whereas non-metals are poor conductors. Yes?
Sir, except graphite.
Yes, yes.
So what is
Leave
the
graphite
difference
right now.
between poor conductors and insulators?
There is no difference between poor conductor and insulators. Insulator also mean that the electric current, insulator also mean that it is a poor conductor. Okay. So the insulators does not allow the electric current to pass through it, but you can, like, if you have very sensitive instrument. Okay, we will come through this activity later in when we will study this chapter, and in which I will tell you that we should never call it as conductor and insulator. We should always call it as good
Yes, sir,
conductors or
because
poor conductors. Okay. So with respect to resistance, what you can conclude between these two, conductors and insulators? First, tell me what is resistance. Do you
sir,
guys understand
resistance is a
resistance?
opposite force that
It's like
stops the motion, sir.
Okay. Anyone else?
Opposes the motion.
Hmm?
It opposes the motion.
It opposes the motion.
A force that
Very
opposites.
good. So we can directly say that it hinders the flow of current, flow or movement of current. Okay. So resistance is the hindrance in the movement of current. Whenever you say that something has high resistance, that means it will not. That means the current through it will be less. And whenever you say that substance has low resistance, that means the current through it will be more. Like more current will pass through it. So can you tell me what is like what will be the resistance of conductors? Will it be low or high?
Sir, low.
Low, very good. So conductors, one is low resistance.
Sir, but alloys have some alloys like nichrome have resistance,
Which resistance? High, low?
high resistance, nichrome.
Hmm. Okay, then what you're saying? If
Like
nichrome,
alloy nichrome has a high resistance, but it can
okay, but it can.
nothing, sir.
So low resistance. So you can say that conductors have low resistance. Then only we can say that it is allowing the electric current to pass through it. Whereas insulators have high resistance. So whenever any current is applied through an insulator, it won't be able to pass through because of the high resistance. Okay. And one unique property of these insulator and conductor is this is conductor, this is insulator. So whenever you apply some external charges, okay, what you meant by external charges, like
Positive or negative charge.
who asked me? Like Manasvi asked me regarding the rubbing of like comb in your hair, and then you get positive, negative charges. So likewise, when you deposit some charges on conductor, when you deposit,
They can
let's
hold
say,
it.
100 electron you deposit, then this 100 electron will distribute evenly at all of its surface. Okay, so what you did, you took this bunch of 100 electrons and you place it here in the conductor. And what is the property of conductor? What will the conductor do? Conductor will distribute these electrons evenly at all of its surface, rather than at single spot. It distribute at all of its surface. So these 100 electrons will be like this: electron, 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 electron. Okay. So that what does that mean? If you are carrying a conductor, and you touch a electric wire, what that electric wire is carrying?
So it's carrying current.
Charge, correct? Current. The current is current is generated from charge only. So that means it is carrying charges. So whenever you touch any electric wire to a conductor, what it will do?
So it will flow the negative charge.
Yes, you can say that it will distribute the charges given to it evenly at all of its surface. Okay, so if you are holding that conductor, so that charges will come to your hand also. Okay, and you will feel a shock. Whereas what the insulator will do, if you are carrying a bunch of 100 electrons, it will, if you deposit it at this place, so these will remain at this place only. If you are holding this insulator from here, okay, if you are holding this insulator from here, so these charges won't travel to your hand. These charges will remain at its own position. So which property is responsible for this phenomena of these two materials?
Sir,
So
conductors have low
conduction,
resistance and the flow of
so
electrons is
conduction
easy.
Yes, conduction also, and you can say the phenomena
and
which we have read now is resistance. Okay, so resistance is responsible for this action. How? So insulator, you know that insulator have high resistance. So when you put this bunch of 100 electron at this place, so due to high resistance, these electron won't be able to move freely on the surface of this insulator. Whereas conductor has low resistance. So when you put this bunch of 100 electron at one place, so due to low resistance, since electron carry kinetic energy, okay, you know that electrons carry energy. So if they have energy, they will try to move on the surface. And when there is no resistance, like less resistance, so these will try to move at different parts. Okay, and if you are holding this conductor, you will feel a shock. Okay, so this is the property of conductor and insulator, that if you supply any if you supply charges on the surface of insulator, it will remain at its own position, it won't move. Whereas in conductor, it will spread evenly at all of its surface. Okay, making it an even distribution. So can you tell me why is it dangerous to touch an electric appliance with wet hand?
so because
Sir,
our hands are good conductors of electricity and will get the shock.
sir, the water is
So water is
a
a very
good.
good conductor of electricity. That's why we can get shock.
Okay, very good. So it is due to the water. So if we if our hands are wet, then we will feel electric shock. Why? Because water is a good conductor of electricity. Can you tell me the water we are drinking, is it pure, or does it contain some salts or and contamination?
Minerals.
Sir, it contains salt.
Minerals.
Yes.
It has
So water is
minerals.
of two
Mineral salts.
types. Okay, I'm not generalizing this water into two types. Like I'm just telling you that we can say that we have some normal water and one is distilled
And
water.
distilled.
So this distilled water, it is pure water. Okay, so what does this pure water means? That it is free from all minerals. It is free from minerals, uh, free from minerals and salts. Okay, so the water we are drinking, it is mixed with different kind of minerals, and due to this mineral, this water, this distilled water is free from all minerals, whereas normal water contain minerals and salts. So due to this, the mixture of minerals and salt in normal water, it acts as a good conductor of electricity. Whereas distilled water, which is a pure water, it does not conduct electricity. Okay. So water also show two type of behavior. That the normal water conduct electricity, whereas distilled water won't conduct any electricity. And why? But because distilled water is a pure water, it does not contain the minerals and salts, okay, which are responsible for the movement of electric charge. Fine. Is it clear to you that distilled water is okay? I can say it as it acts as poor conductor, or I will say it insulator. Okay, insulator. Fine. So you guys must have heard about tester. What is tester?
Sir, a device that checks the flow of electricity and also yes sir, it checks the flow of electricity and
So it can be used to check whether a material is a conductor or a poor conductor.
Okay, very good. So it is a device which is used to check if a
The
material
conductivity
is a
of a
conductor.
material.
Okay, very good. Have you seen something like this?
Yes, sir.
Okay, so this is like this part from here to here. This small thing is known as tester.
That-
Okay, let me take some different color. Okay, so this small thing acts as tester. Can you tell me the mechanism behind this tester? How this tester is working?
sir, if we add a conductive material to attach both of the wires, like the free ends of wires, if it is a conductor,
No, I'm not
the
asking about conductor. I'm only asking about tester. Can you tell me how tester works?
it checks the
Sir,
it
if the
checks if
electricity passes, it will glow. If it does not pass, it will not glow.
Okay, very good. So
Sir,
if what
it
is
glows, we'll
here,
understand that it's a conductor.
conductor and insulator, that is different thing. Right now we are talking about this only, the red circled part. Okay, so this is a tester. So what is tester? Tester contain one cell. Okay, this cell is supplying charges. Okay, this cell is supplying, this is supplying charges. Okay, so let's say if this is positive terminal, can you tell me which one is positive and which one is negative in this cell?
sir, positive
Okay,
is
so
the down part.
the front part is positive and it is supplying positive charges. Okay, and we took a material, we attached this positive terminal with a wire, and we attached this wire to some conductor, and then we attach this conductor to some bulb. Okay, to check if there is an flow of current or not. So we, from positive charges, what are coming? Protons. So these protons are coming, and these will go through this wire, and this bulb will glow. Okay, so the main work of tester is to check if any substance is a good conductor or a poor conductor. If it will be a good conductor, then the electric current will pass through that material and this bulb will glow. Can you tell me the significance of bulb in this tester? Is it necessary to have bulb or not?
Sir, it is necessary.
It is necessary. Why?
Sir, because we cannot normally check without the bulb, sir. Like if we cannot check the if it is passing current or not without the bulb
Exactly. We need an indicator. We need an indicator that if this current is passing through or not. Okay, so we need a particular type of indicator which tell us that if this current is passing through or not, and the bulb acts as a very good indicator. Okay, so with the help of bulb, if this current is passing, it will glow, ultimately telling us that the current is passing through. But if this bulb is not glowing, can you tell me what material we will be using?
Insulator or poor conductor.
Insulator or poor conductor. Very good. So this part, this only acts as a tester. Okay, and when we use this, there are two terminals, one terminal attached to the bulb and one terminal attached to the battery. Okay, and whenever we complete this circuit, how we complete this circuit? We will attach
If we
one part.
attach the an object with both the ends of the wires.
Correct. Okay, so what the complete circuit means, that all the wiring is closed. Okay, let's say I give you an example. If I have circuit and there is a bulb, this is positive, negative, battery. Can you tell me, will the current flow through it or not?
No, sir.
No, sir.
No, sir.
No, sir.
Why?
Sir,
Sir,
because
because
it's
the
an open
circuit is
circuit.
incomplete.
Circuit is incomplete. So here, circuit is
It can also be called an open circuit.
open. Okay, so circuit is not complete. If I complete this circuit and I join it, both the terminal, will the current flow, will the bulb glow or not?
Yes, sir.
Yes.
Okay, it will glow. So what does this thing tell us? That we need a circuit to complete the sorry, we need a
Conductors.
complete circuit for the flow of current. Okay,
Yes.
we need a complete circuit for the flow of current. Let me take one example. If you are touching an, like say, open wire, okay, you are touching an open wire, you will get electric shock. Okay, tell me if you get electric shock or not.
Yes, sir.
Okay, you get electric shock. Some birds sit on the wires which go through the poles. Okay, the high voltage wires which go through poles, and birds sit on those wires, and still they do not get the current. Why?
Because the copper wires are covered with rubber that's insulator.
No. Manasvi, I take your example. If you go and touch those wires, you will ultimately definitely going to get shock.
So if we touch the copper wire inside,
sir,
we'll
if
get the
birds-
current, but the rubber is an insulator. If we touch
bird-
that, we won't get the current.
Sir, if birds sit on the wire with one leg, they get a shock. If they sit with two legs, they do not get the shock.
Not necessary one or two. Okay, let me tell you. So let's say there are, this is pole and this is another pole, and they have 2 to 3 wires. Okay,
Sir, one is called earth wire, right, sir?
yes, one is earth wire. So they carry a same type of the charges in one wire, let's say positive charges, and other type of charges, like say negative charges on other wire. Okay,
Sir,
so
if a bird sits on both of the wires at the same time, then it gets a shock.
correct. Okay,
Then
correct.
if a bird sits
So
on one,
let's say there is a bird having 2 legs, and if it is sitting on one wire only, then the circuit is not complete. Okay, the circuit is not complete. Why? Because this is only one wire carrying positive. Fine, the circuit is not complete. The, like you say, the current which was coming from this side will again pass through here only. Whereas if you stand, let's say if you stand here and touch this wire, you will definitely get a shock. Why? Because the current coming from this, you complete the circuit. Ultimately, you complete the circuit. If you touch this wire, the current will come through you and it goes to the ground.
earthing.
Or you say earth. Fine. So in this case, what you are doing, your legs are touching the ground. Legs are touching the ground, And if you touch those wires, the high voltage wires which are going over the poles, so the current will pass through you because you completed the circuit, and the circuit is most important for any electric current to pass through. Whereas this bird is not completing any circuit, because the current which was coming on wire is still on the wire. Okay, it is still on its way. And if this wire if this bird puts other leg to another wire which is carrying the
Then you'll
opposite
get
charge,
shock.
so in this way, what is happening? This is positive, this is negative, and if we connect these, then a complete circuit the circuit is completed. And due to this, the bird will get a shock. So in this situation also, you can like create a fantasy situation. Like if you imagine, if you can fly, okay, if you can fly and you go touch that single wire, you won't get a shock. Why? Because the circuit is not completed. And what you do, touch both of the wires simultaneously. In that case, you will get a shock because the circuit is completed and the current will pass through you. And whenever the current pass through you, it will give you shock. Do you anyone has any doubt in this?
No, sir,
No?
no doubt.
No, sir. No, sir.
No. Okay. So can you tell me if liquids can conduct electricity or not? I'm talking about general
Sir,
liquids,
based on
not
some conditions.
water. Okay. Based on some condition, what are those conditions?
Sir, it should have
It should be an
it should be an
acid or a base.
electrolyte.
Have
It should be an
salts or
electrolyte. It should either be an electrolyte, or it could be an acid or a base.
Okay. Dhriti, what were you saying?
Sir, it should be an acid or a base, or it should have minerals or salts in it.
Okay, we should have that type of salts or something to have for what? For the liquids to conduct electricity, right?
Yes, sir.
Okay. Let me take one. Let me open this. Do you guys read NCERT?
Yes.
Okay, yes. So you guys should read NCERT because it is the most important at your until 12th. You all of the questions and everything comes from your NCERT. So I'm taking this activity number 11.2. What I'm doing here, we collect a few small plastic or rubber caps of discarded bottles and clean them. Pour 1 teaspoon of lemon juice or vinegar in one cap. Bring your tester over this cap and let the ends of the tester dip into lemon juice. What are those ends of the tester?
The free ends of wire.
The
So
wires, sir.
these two wires, these two are the free ends, and we are dipping these in the cap. Okay, the cap which is containing the lemon juice. So bring your tester over this cap and let the ends of the tester dip into lemon juice or vinegar as shown in figure 11.2. What is 11.2? This. Likewise. Okay, and as I have told you, what is tester? Tester is a combination of a cell or battery with a indicator, a bulb. Without bulb, we won't get to know if the electric current is passing through or not. Okay, so we need bulb and indicator. Now take care of that ends are not more than 1 centimeter apart, but at the same time do not touch each other. Does the bulb of the tester glow? Does lemon juice or vinegar conduct electricity? How would you classify lemon juice or vinegar, a good conductor or a poor conductor? Tell me.
Sir, it is a good conductor, sir.
It is a bad conductor. It's a poor conductor because it's an organic acid. It's an organic acid.
Okay. And who said it will conduct? Okay, sorry. Never mind. So what will happen in this solution? Others try to think what will happen. Venesha, Rohit, Dhriti, Jitendra, Manasvi.
Right. Sir,
Mhm.
the bulb glows dimly. If it's not LED, then it glows dimly.
Okay. Ashwath has very low patience that he goes through all the text before we come to it. No need to hurry this much, Ashwath. We will come to it. I know you can read NCERT. Very good. That is a good skill. But right now, we are trying to learn what is happening. You should first apply your own brain and then you should seek the correct answer, that what should be the correct answer. Otherwise, there won't be any development or any growth in your knowledge. Fine. Let's move forward and then we will come to know that what will happen in this case. Okay. Let's read this part. So when the liquid between the two ends of the tester allows the electric current to pass. Am I audible to you? Can you hear me?
Yes, sir.
Yes,
Okay.
sir.
So when the liquid between the two ends of the tester allows the electric current to pass, the circuit of the tester becomes complete. Okay. Now, do you know what is complete circuit means?
Sir, when the wires are connected and when the circuit is complete, it means that there's no free ends, sir. Like
So in this case, let
So
me
there's a
say this.
complete closed path through which the current can pass through.
Okay, correct. Complete closed path. So in this case, I am like dipping one end here and one end here. They are not touching each other. So how you can say that
sir,
it is a
but
complete?
lemon juice is a conductor, right, sir? Then it like it is supporting the path.
So lemon juice is a material, okay, a liquid, which if we dip both of these part in the same lemon juice, so there would be some particles or the material which will carry that current to the other end. So ultimately,
The free ion.
this circuit will be complete because of this liquid. Okay. So it does not matter that we are taking liquid, not a solid. And if we are saying that if it is a complete circuit, then liquid also completes a circuit. How? Because it carries that electric current from one point to another, from here to here. So it is ultimately completing the circuit. Fine. The current flows in the circuit and the bulb glows. When the liquid does not allow the electric current to pass, the circuit of the tester is not complete and the bulb does not glow. So there are some liquids also which does not allow electric current to pass through it. So these liquids will act as a insulator, whereas the liquid which allows current to pass through it, then those are conductors. Okay. In some situation, even though the liquid is conducting, the bulb may not glow. It may have happened in activity 11.2. What can be the reason? So
Sir,
these type of activity, like if any activity is given to NCERT, so it is ultimately saying to you that you need to do it by yourself. Okay, so we cannot, like, theoretically we cannot say that if a material will be conductor or not. We need to perform the experiment by ourselves. We, like Ashwat said, that it is an organic material, so it won't conduct. Does not matter if there is vinegar. Let's say if vinegar is containing some other material also, some other element which is a good conductor, so then it will conduct. Does not matter if vinegar is
sir,
a
organic acids do not like they cannot be considered insulators, but they can be considered poor conductors, right, sir?
yes, poor conductors. So let me tell you this thing. You are getting the material in your house. Okay, you get vinegar or the lemon. What was here? Lemon juice, right?
Baking soda. Yes, sir.
Lemon juice. Lemon juice. Okay. You get a packed material. Okay, you get a packed material and you take it at your home and you consider it as a pure. Okay, our mindset is that that material will be pure, but actually it is not pure. The industries, the companies which are sending this material to you add different kind of material elements or compound in your product, so that it gets more lifetime, and that material do not get spoiled. Okay, so very numerous things are added in that the product you are bringing at your home. Fine, due to which it does not remain as pure. So lemon juice, like let's say you are bringing lemon juice packing of a lemon juice, and you are creating lemon juice by yourself, taking a lemon and mixing it in water and all this thing. And so these two lemon juice won't be same, because there some in the packing lemon juice there might be some other ingredients also, which does not make it a pure lemon juice. Okay, I think you guys understood what I'm trying to explain. So the all in short, if I tell you that the packing material you are taking at your home, it is not pure. It is never pure. If it is saying apple juice, so it does not contain all of apple juice. It contains some other material also. Okay, which may be harmful. Okay, so there are some material also which may be harmful. Let me tell you one fascinating thing. So you guys must not have read about the sex education, right? You guys do not know about sex education, right?
No, sir.
No. Okay. So let me tell you one thing. Okay. Wait a second. Let me connect my laptop to the chargers. Wait a second. Okay. Here we go. Can you hear me?
Yes.
Yes, sir.
Yes, sir.
Okay, so first thing is like uh, there is not much education about this in schools and all, like uh, how there is like a need of these kind of education in our schools also, so that everyone get to know about yourself and about like humans. Okay, so you can say that there is a social debate then that if we had sex education in our schools, then all of the cases, the rape cases and all of the harassment cases, they won't be that much dominant. Okay, so the basic thing we are lacking is these kind of education, which if it were there, then they would have taught you more about the human body, not about like other things. So okay, so I was telling that uh, they in the males have testosterone. Okay, so males have testosterone. These testosterone is responsible for the like responsible for producing.
For producing sperms.
Yes, correct. It is responsible for producing sperm. And in females, there is estro,
Estrogen and
estrogen,
progesterone.
estrogen. Okay, very good. You know. So the females have estrogen. Sorry, estrogen. So there are some perfumes. Okay, perfumes. Is this correct spelling? No. There are some perfumes that only come from males. Okay, that males apply that perfume, and it is good for fragrance and all. These Some of these perfume contain paraben. Okay, paraben is an ingredient which is applied externally. Okay, so what this paraben do? If you apply this perfume on your skin, or so if you are applying it on your skin, this
It will
material
burn.
paraben is going through, not burn. It never happened that if you apply perfume and you will get a burn. Okay, so if there is a perfume which contain paraben and you apply it on your skin, this paraben will go through your skin and it will travel through your body. Same is the situation in the smell. This paraben also gets out in the smell, the fragrance, and it goes through your nose and it travels inside your body. So ultimately, what I'm saying that this paraben travels in your body. So what this paraben do? It decreases the level of testosterone. Okay,
Yes,
do
sir.
you get it? Do you get it? What I'm trying to explain?
Yes,
That
sister. And it is E, it seems, not I, paraben. It's like,
it is what?
like in Google, it's like paraben,
Paraben.
not
You
I.
are said.
It is not I in hand. It is
Okay,
E.
what? E. Okay, paraben. Okay, so this paraben decreases the level of testosterone. And as I have told earlier, that the due to testosterone only, the uh, uh, the sperms are produced. Okay, which is further used in the process of reproduction. Okay, so can you imagine that with the use of this one material, the perfume and the paraben present in it, it decreases the level of testosterone, which is ultimately hindering this process. Okay, So this small thing, this perfume is creating so much dangerous effects on human and ultimately on males. So this increases the level of what was that spelling and the pronunciation? Estrogen. Estrogen.
Estrogen.
Yes, it increases the level of estrogen, whereas it decreases the level of testosterone. So these kind of perfume are actually harming the males. So when you get products from the market, these products are never pure. These always contain some contamination, some external ingredients, due to which it one way or another these product will harm you. Okay, so this was very shocking when I read about this, that no one imagined that even a perfume can be this much harmful. Okay, that it can lead to these kind of side effects, but it is actually happening, that most of the premium perfume contain paraben, and this paraben is very harmful for.
Sir, so nothing can cancel a paraben.
Nothing can cancel a paraben. Fine. So what were we were talking? Okay, so we were talking that this activity, you need to do these kind of activities present in the NCERT by yourself, so that you can conclude if what would be the results out of it. Fine. Okay, so this solution of vinegar and the lime juice won't like complete the circuit, and the bulb will not glow. Okay, so let's read ahead. Do you remember why the bulb glows when the electric current passes through it?
So heating
Can you?
effect of electric current, because of the heating effect, light is created. The filament of the
Correct.
bulb is made of tungsten, and
Okay.
when electric current passes
And the
through,
tungsten is
distance
heated
to
to a height.
produce, which produces light.
Okay, very good. So
Tungsten
let's
is
say
heated to a very high temperature, sir.
if
And it
there
emits
is a
light.
bulb, if there is a bulb, okay, this bulb contains tungsten. This part, this is tungsten. And when electric current is passed through it, this tungsten gets heated up. How this is heated up? Okay, if I am
Resistance.
taking a resistance, correct?
Towards the electric
Yes, sir,
current.
resistance.
Correct. So resistance is always represented by this sign. Whenever you say there is a resistance in a circuit, you always draw it like this. Fine. So this is resistance. And the electric current is passed through it. Now, who was on that day? It was, I think, so he's not present. Let me ask Jitender. Jitender, I explained what is resistance and how it affects the flow of electric current. Can you tell me the example I told about a classroom and the number of students?
Yes, sir.
I'm asking.
Sir, resist.
Hmm. Yes, tell me. Resistance. Yes, Jitender.
Yes, sir.
You were telling about resistance.
Yes, sir.
Okay, don't worry. So I gave one example of, let's say, Rohit. I'm taking Rohit, and he asked his teacher that he need to go for a washroom in between a class when there is no rush in the hall. let's say this is class, this is washroom, and there is this hole in between it. Okay, and there is no rest, so Rohit will easily go there. Fine. And I'm taking one more situation in which the bell has rung, the all class over, and now students are going to home. Now, if Rohit wishes to go for the washroom, suffer resistance or not? Tell me, Rohit, will you suffer resistance or not?
Sir, I didn't understand your question. Can you repeat?
So I'm saying that I am taking two situations. In one situation, you went to the washroom in between class. Okay. And in the second situation, the bell has rung, all classes are over, and now students are going to their home. And in that situation, you wanted to go to the washroom. In which situation you find difficulty to go to the washroom?
Sir, when we're going home, since maybe the buses will leave,
No, no. I think I'm
Sir,
not able to.
Sir, the hallway or the corridor would be
yes,
Okay.
full of
maybe the first case, since because during classes some people will also be in the washroom, so there might be a rush. Then I
Okay,
won't be
let
able
me take
to.
the situation like this. In first situation, there is no one in your way. There is no one in the washroom. In the second situation, there are many students studying, standing here. They are crossing this hallway. And, okay, and there are some inside also. Okay,
Yes,
so what you will do? You in first situation you will try to go there, and you will go there easily. Okay,
sir,
no
but in the
resistance.
second one, I'll get stuck because of the rush in the hall.
Correct, you got stuck due to the rush in the hole. Fine, so in the second situation you are facing a resistance.
Sir, while in the first one, it's sir, then what will the first one be?
In the first one you won't face any resistance. We can say in this case it was high resistance. In the first one it was no
No.
resistance, no resistance, or you can say low resistance, low.
Yes, sir.
Okay, so in first case there was no resistance, in second case there was high resistance.
Right. Yes, sir.
Now if I tell you that you need to go very immediately, that there is an emergency and you need to go no matter the cost, you need to go to the washroom as immediately as you can. So in that case, will you collide to some students? Will you face some collisions and all?
Sir, probably yes, because they might, because of the rush, we will
Mhm.
collide because there will be too many people in the hall and it won't be easy like in the first case when the
Okay,
halls are empty.
so can I take this collision as a heat?
Yes, sir.
Okay, correct. So when you collide to some student, they will like get angry and they will try to beat you.
Yes,
Okay,
sir.
and you will again collide to some other student. They will try to beat them. Okay, so in when there is a rush, there is a huge crowd. No one ever figure out that who pushed one person to another. So the people ultimately think that the person behind them pushed them. Okay, so they will try to beat that student. So in that case, there will be very much like heat in that environment. Similar is the case in the circuit. When there is a resistance, so in high resistance, the current will try to flow. Okay, the current will resist. The current will try to flow through it, but the resistance won't allow to flow. Okay, so in that case, there will be some heat generated to it. Fine. So this is the like the reason behind the generation of heat, because the resistance isn't allowing the current to flow, but the current need to flow. Okay, there are free electrons that contain some energy, so they are trying to get passed through it, but the resistance will not allow to flow. So in that case, there the heat will be generated.
Sir, heating effect of electric current.
Correct. heating effect of electric current. And the tungsten we are talking about, this tungsten is a resistance.
Alloy.
Okay, this acts kind of a resistance. So when electric current will pass through it, this electric current will generate a heating effect. This will lead to a heating effect. Okay, why heating effect? Because the tungsten has a resistance. Due to this resistance, there will be a heating effect, and the tungsten will become hot. Due to this heating effect, the tungsten will become hot.
Yes, sir.
And it is the property of tungsten that when it becomes too much hot, it will start glow. It starts glowing. It starts glowing. So this is the reason behind why we see bulb glowing. Whereas we are providing electric current to the bulb, and bulb is providing us light. So how this light is coming? Because the tungsten is getting warm, it is getting hot. As it is getting hot, it is glowing. Okay, fine. Anyone has any doubt?
No, sir.
Okay,
No,
let me take one more minute and then we will conclude. And let me tell you that we will have one extra class also, because our syllabus is lagging behind. We cannot complete, like we are not able to complete this chapter in 1 or 2 classes. So we need to take one more class so that we can cover sufficient part so that you will get this in your test. Otherwise, we will always be hanging on light and light and light. Every week we are getting test on light. Okay, so we need to do this. And one question is remaining from the light that we need to discuss. So keep this in your mind and remind me if I forget. But first, let's do this syllabus. So due to the heating effect of current, the filament of the bulb gets heated at a high temperature and it starts glowing. However, if the current through the circuit is too weak, the filament does not get heated. Okay, heated sufficiently and it does not glow. And why is the current in the circuit weak? Did you understand what this statement is trying to tell us?
Yes, sir.
Yes, sir.
So it means that if I do not supply sufficient amount of electric current to the tungsten won't get heated. And if this tungsten won't get heated, the sufficient heating. Okay, so the tungsten also require sufficient amount of electric current for it to heat that much that it starts glow. But if let's say I'm not providing that much amount of electric current, I'm providing very low. Let's say earlier let's say the tungsten takes 10 ampere current. Do you know about this ampere? What is ampere?
Yes, sir.
What
It's
it is?
it's a unit to measure the electric current, sir.
Very good. So ampere is the unit of electric current. We always measure current in terms of ampere. So let's say the tungsten required 10 ampere current to glow, to get heated, whereas I'm supplying 5 ampere only. So in that case, the tungsten won't get heated and it won't glow. It won't supply us light. So this is the meaning of weak current. Okay, the current which I am supplying is too weak, due to which the tungsten does not get heated and that it won't start glowing. This is the same case in this solution also. This solution is supplying some current, but it is not supplying that much current that this bulb starts glowing. Okay, so it is supplying a weak current. It is supplying a weak current, which due to which the bulb cannot get heated sufficiently and it does not start glow. So how we can like remove this problem of weak current? How
Sir, we have to
what we
use more number of electric cells, or we can use a different source of light. So like we can use a different object that emits light. Like for example, LED. It can glow when there is less amount of electric current.
Very
Or
good. That means if we supply more and more current to the solution will this weak current will increase. Okay, else we can use LEDs. So instead of this bulb, we can use LEDs. These LEDs can glow even at low current, at a weak current. Okay, and these LEDs can work as a source, as an indicator. If we use LEDs, then we are able to detect weak current also. Fine. So with this situation, we can conclude that we can never say a material as a conductor and an insulator. We should always say that a material is a good conductor and a poor conductor. Fine.
sir, because in some condition, like when lightning happens, air which is a poor conductor can become a good conductor of electricity.
Correct. Because the lightning which is happening in the sky, the air is a poor conductor of electricity. Like you never see any current traveling in the air and you getting shocked. Okay, it never happened that there is some current leaking in a transformer, the transformer or the wires, and you get an electric shock just standing behind that wire, because the electric current never travels through air. But we see that the lightning which is coming from the sky, the clouds, that is traveling to the land, and you can also observe that it causes damage to the ground also, in the trees, in the buildings and all. How the lightning is traveling in the air then?
Sir,
Okay.
the okay.
So the electric this and the we cannot say that a material cannot carry current. We can say that it carries current but very less. So all materials carry current, all materials can conduct, but it depends on the magnitude, whether you can conduct less or you can conduct more. So in that respect, we always say a good conductor and a bad conductor, a poor conductor. Okay. In some situations, every material can conduct electricity. So let's stop now and we will continue from here on. Fine. Anyone has any doubt?
No, sir.
No, sir.
Great. Then let's meet in our next class, the extra class. We will be having an extra class. Okay. Can you suggest me a day in which you don't have any classes?
Sunday.
The Saturday.
There's
Saturday. Okay. Before Saturday, so Thursday, Friday, do you have any free
yes,
No,
sir.
sir.
slot?
Thursday, Friday, and Saturday we have our maths class.
Yes, sir. We have a maths class.
Okay, on Saturday also you have a math class.
Yes, sir.
Okay, no worries then. We will try to take the extra class on Sunday, or we may not take that class. I
Sir,
will.
Tuesday we don't have any class of Chanakya.
Okay, we don't have any class on Tuesday. Fine. You guys read until now, which I have told you, and you can try this experiment at your home also. This tester and last thing, tell me any tester you see in your surrounding.
Sir, actually there's an appliance called tester, right, sir? It looks like a screwdriver.
Screwdriver, correct. So
It also has a
there is a
circuit inside it. So when we press a button and we put it on the circuit, sir, or a conductor, if we put it on a conductor, if we press the button on the top, then if the bulb glows with inside the tester, then it's a conductor. If it doesn't, then it's a insulator.
correct. So we use this type of tester in our homes to check if the circuit board is supplying current or not. Okay, and how this tester is working, the electric current which goes through the screwdriver, it goes to the bulb, the bulb glows, and then the current comes back, like it completes a circuit. So due to this completion of this circuit, you can see the bulb, the small LED bulb which is there in the tester, glow. And why we are using small LED bulb? So that we can detect even small currents also. Okay, you won't see a tester, the screwdriver tester, having a big bulb, because if you attach a big bulb, it will glow at large, at a good amount of current, but it won't glow a weak current. Fine. Okay, let's meet in next class. Bye bye.
Bye, sir. Thank you for the class.